Okay, so like I said, we are graphing sine and cosine, and basically all we're going to be doing for the next couple days is adding on a new transformation that's happened. So on like the last lesson, we talked about the number outside of the sine or cosine and how that affected the amplitude, which just made it go taller or shorter. We're going to do something similar today. We're going to look at a number instead of like outside, like 2 sine of x, it's the number on the inside and how that actually changes what it looks like. So to start out, let's graph. We're just going to look at the graph of sine of x again. Oops, sine x. And I am going to adjust my window so that way we're only going to look at one period here. So I'm going to start at, we'll say like -1, and I'm going to go to like 7, and then I want, that'll be fine, and then I want this to be like -1 and, well, -2 and 2. So that way we can see sine a little bit better. Okay, so there's one period of sine. Remember, a period is like the length of the cycle, so we're starting at 0 and then we end here at 2 pi before it starts repeating itself. Now I'm going to graph the sine of 2x and see what that looks like. So as we look at that one, so here's our normal sine graph, and here's our sine of 2x. What's happening is that it's going faster. It has like a faster frequency. So it actually only takes, if I look at, I'm going to get rid of sine x here. If I just look at sine of 2x, to actually complete that cycle before it starts repeating is 0 to this number here, which is 1, 2, 3 and change, which ends up being actually pi, 3.14. And then it'll complete a new cycle in the same amount of time here at like 6 and change, which is 6 times, or 3.14 times 2, which is 2 pi. So if I graph sine it with it again, you'll see that it crosses here. This is at 0 for sine initially, which is at pi. So this completes the whole cycle. The sine of 2x completes the entire cycle in the time that it only takes our first one to complete half the cycle. So then I'm going to graph sine of 3x. So this one again is our normal sine function. And if you can imagine, like what's going to happen is that we're going to go even faster. So if I'm going to count the amount of cycles this happened in the same, so remember this is a regular sine, it completes it in 2 pi units. So here's the end of the cycle. We complete 1, 2, 3 cycles in that same time, which is where we're getting the 3 from. So what happens is that this is a normal period of 2 pi, and this goes twice as fast with the 2 in there, and its period, since it goes twice as fast, it completes a period in half the amount of time that this one does. So I would do 2 pi over 2, which ends up just being pi, and that's what we saw. And this one goes 3 times as fast. Which means it completes the period in 2 pi over 3 units. So it completed 3 periods within that 2 pi. So this generic, or this idea of taking the value that we have, like seeing how many times faster it goes, and dividing it by our normal period is how we're actually going to get our generic form to find the period, is 2 pi over b, and b is that number that's in front of x in either like sine or cosine. Remember, a is the amplitude. So now we have a new kind of standard form that we're adding on. So last lesson we just looked at that one piece with the amplitude, and that was our standard form. Now we have a new section to deal with for our standard form, and it's the period change, how if we're going faster or slower. So b is the number of cycles that it completes between 0 and 2 pi. We saw that if the number here is 2, then it completes 2 of them within our normal cycle of 0 to 2 pi. And if we had 3, it completed 3 of those cycles. If that b value is bigger than 1, then our thing goes faster. Our period is shorter. It is a faster cycle. And if it's between 0 and 1, then it's a longer period, which means that it goes slower. So for example, we'll just look at that real quick. I'm going to delete these, and I'm going to pick a sign or a value that would be between 0 and 1, like 1/2 x. So again, our first one is that's getting graphed is normal sine. And then this is the sine of 1/2 x. So you'll see that this one completes half of the cycle, and it would continue on. We just don't see it in our window right now, but it completes half the cycle in normal 2 pi period. So our cycle for that, since it takes halfway to get to 2 pi, it would complete it over here at 4 pi. So it would be twice as long to have that 1/2 there. Okay, so we have a couple steps. First is to find the period, and we're going to do that by using our formula 2 pi over b when we're graphing this, and we're going to label the x-axis. Remember how we talked about those 5 critical values? It's still going to be just as important that it happens here, so we need to make sure that we're actually labeling those and labeling your x-axis. If you don't label those, you don't get credit for those finding the period and actually finding your critical values. So it's really, really important that you do that. And then we're going to actually use a specific way to find the critical values and the in-between part. So we're going to find like the first critical value and then the last critical value, and then we're going to find the respective averages between those to actually go through the critical values. Now, there are different ways to do this, and you might be able to do this faster right now, but long term, when we add on, it's going to become more and more complicated about how we actually do that. So I want you to practice finding the average now, so that way you can figure out how to do that when it actually gets more complicated. And then last but not least, we're going to figure out our amplitude. Okay? And I would actually label the amplitude first, just so that we can get it out of the way, but we're going to use the amplitude to graph it really. So we're going to find our amplitude, we're going to find our starting x and our ending x. And to do that, we need to find our period. So we have kind of like 4 different things right now that we're keeping track of as we find our graph. Okay, so our period is going to be 2 pi, this is our b. So our period is 2 pi over b. That's how we find that. So our b value is 4, so 2 pi over 4 is our period length, which if we reduce that down is pi over 2. So our starting value right now for sine is 0, and then our ending value is going to be the end of our period, which is pi over 2. So we're going to start here at 0 and then end at pi over 2. And then we're going to find the average. So this, we can ignore the pi right now. Really what we're looking for is the average between 0 and 1/2. And you can do this in your calculator, like 0 plus 1/2 divided by 2. And that might help you, especially later on when it's harder to actually calculate. But if I do that, 0 plus 1/2 and divide it by 2, I get pi, I get 1/4, which is going to be pi over 4. And then I'm going to find the average between each of these. So now I'm dealing with the average of 0 and 1/4. So 0 plus 1/4 divided by 2 is 1/8, so pi over 8. And our next one, 1/4 and 1/2. So 1/4 plus 1/2 divided by 2 is going to be 3/8. So 3 pi over 8. And again, like you can do that in your calculator. So I would do like 1/4 plus 1/2 divided by 2, and I can change that into a fraction on my calculator, and I get 3/8. So there we go. That's going to be our spot here, the average between those. So those are 5 critical values that we're labeling. And then we're going to deal with our amplitude. So we're going to go up 3 and then down 3. For sine, our normal sine looks like this. So we're going to start here at 0. We have a 0 in the second critical value, or I guess 1, 2, third critical value, and then their fifth critical value, one at the last. And we're going to go up 3 units and then down 3 units. And then there's our sine graph. Something like that. Okay, let's do that again. So we have our amplitude, we're going to find our period, and then that's going to help us find our starting x and then our ending x. And again, right now it's maybe not necessary to keep like a running tab of what's happening, but I promise you once we get more and more complicated, it will be really helpful to actually do that. So our amplitude is 2 and we have a negative. So I'm just going to jot down that I'm going to have a reflection, which means that normal cosine starts at like up here on the x-axis and goes down like that. So we'd be going down and then up to come up with our normal cosine. Our period is going to be 2 pi over our b value, which is 3 over 4. So to solve for that, I'm going to multiply by the reciprocal. So I'm going to take that top part, which is 2 pi over 1, and then multiply by 4 over 3, which gives me 8 pi over 3. So that'll help me with my starting x value, which happens at 0, and my ending x value that happens at 8 pi over 3. So 0, and then 8 pi over 3. And again, if I'm finding the average, because that's going to be my first, like this is my first critical value, my last critical value, this will be my third critical value. To find the average between 0 and 8 thirds, I do 0 plus 8 thirds, which is 8 thirds, and then divide it by 2, which will end up being 4 thirds. So 4 pi over 3 is the average. Same thing here, I'm going to find the average between 0 and 4 thirds. So 0 plus 4 thirds divided by 2 ends up being 2 pi over 3. And then 4 thirds and 8 thirds, which is 12 thirds divided by 3. And then I'm going to divide that by 2, so it'll be 6 pi over 3. And again, like if you need help with those average stuff, especially like now it's not too bad because it's easy to actually come up with this. So this will actually reduce down to 2 pi. So you could write it as 2 pi if you wanted to, but you could leave it like that, and that's fine with me. But anyway, like although there's other ways to do it right now, later on when we actually look at it, it'll be a little bit harder to actually come up with these averages. So if you need help figuring that out, like how to do it on your calculator or whatever, just let me know. And our amplitude is 2. So again, normally cosine starts here, has a 0 at our second critical value, and I'll have a 0 at my third critical value. Those zeros don't change, but instead of going up and then down to this value and back up, we're going to start, since it's a reflection, we're going to start here at -2, go up to our 0, up to +2, down to our 0, and then back down to -2. So if I connect that, I get this smooth curve for our cosine graph. Okay, so we're going to do this one together, and then I kind of want you to do example 4 on your own once we get there. So our amplitude, oops, I didn't actually fill that in for example 1. Our amplitude, our period, our starting x, and then our ending x. Okay, so our period, well, our amplitude is 2, but we have a reflection. So we can't forget that normally this is what our sine graph looks like. So we're going to be starting here and then going down and then back up. Our period, this is our b value, so it's going to be 2 pi over 2, 2 pi over b. Again, this is something that we're going to have to simplify a little bit better. So this will be 2 pi over 1 on top, and I'll multiply by the reciprocal on bottom. So flip that over and multiply by 2 over pi. Our pi's cancel, and then we get 4. Which is kind of weird as a period to have it in terms of not pi, but that's because we have this pi over 2 value there, which ends up canceling out the pi, and our period will just actually be in whole numbers this time. Our starting x value is going to be 0, and then our ending x value is going to be 4. So I know it's like kind of freaky to label your x-axis in terms of just regular numbers and not pi's, but it works out because we have this pi value for our b. So our starting is 0, our ending here is 4. Find the average between 0 and 4, that'll give 2. Find the average between 0 and 2, it gives 1. Find the average between 2 and 4, gives 3. And our amplitude here is 2. Normally sine has a 0 at 0, 0 at our third critical value, and 0 at our fifth value. That doesn't change. Normally sine goes up, back down. We are going to be going down this time because we have a reflection. So we're starting down at 2 and then back up to positive 2. So our sine graph looks like that. Kind of missed 2 here, but yeah, there it is. And again, it's really important that when you are labeling and graphing your sine and cosine values, that you have your x-axis labeled with all of your critical values. That's what I'm looking for to give you full credit. Okay, last one. If you want to pause, I would, to try to just figure this out on your own. Finding your amplitude, finding your period, finding your starting x value, finding your ending x value, and then finding the corresponding averages that go along with it with all of your critical values. This would be a good one to test it on. So I'm going to make a list of my amplitude, my period, my starting x, and my ending x. My amplitude in this case is 3 over 2, which is 1.5. Normal graph, no reflection, which helps. Our b value here is 5, so our period is going to be 2 pi over 5. Our starting x value is 0. Our ending x value is then 2 pi over 5. So we have 0, we have 2 pi over 5. If I want to find the average between 0 and 2/5, 0 plus 2/5 is 2/5 divided by 2 is only going to be 1/5. So that'll be pi over 5. If I want to find the average between 0 and 1/5, 0 plus 1/5 is 1/5 divided by 2. It's going to be 1/10, which is pi over 10. And then the average between 1/5 and 2/5, so 1/5 plus 2/5 is 3/5, divided by 2 is going to be 3/10, so 3 pi over 10. So those are our critical values there. Our amplitude is 1.5, 3 over 2. So cosine normally starts at 1, so we're going to start at this case at 1.5. We have a 0 at our second critical value, which in this case is pi over 10. At pi over 5, we're down here at negative 1.5. At our fourth critical value, we're at 3 pi over 10, which is going to be a 0. And then our last critical value, completing our cycle, is going to be at the 1.5. And if I connect my points in this smooth curve, we have our cosine function. So again, big ideas for today is that period that has a b value that's bigger than 1 will make our period go faster, or shorter, and it'll make our periodic function go faster, that it'll have a higher frequency, it'll complete more cycles within that normal 2 pi range. So it'll like go twice as fast, or this case would be like 5 times as fast, so it completes 5 cycles in there. So to find out our period length, we just take our normal period, which is 2 pi, and divide it by that b value. And then to find our critical values, we just take the average as we go in from the first and the last critical value, and then the first and third and fifth critical value to find all 5. again, like what we're going to do later, right? Because right now there are different ways to do this, but when we actually add in horizontal shifts, it makes for finding those critical values a lot harder. So we're not just always starting at 0, which is why like now it's kind of stupid that we're always like writing on our starting value, but this will change and it'll affect like our ending x value, and it'll affect our period length and how we go from there. So it's a good idea to just kind of keep track of things as we go, because knowing that it'll get harder and it'll change later on.